Okay, this is going to be a relatively quick video on how to remesh and reduce this monster asset into something more reasonable for a real-time engine to utilize. Now, what I mean by a monster asset is if you see up here under the try count, it's 225,000 triangles. And if I bring the hypershade up here, you're going to see he's 11 draw calls. So basically, he has 11 materials assigned to him. So if I go here to the body shader group and select objects, right-click and select objects with material, you can see I have a material assigned to his body, and those are all laid out in the UV space 0 to 1. I have his cloak UV'd and textured. I have his gun arm over here broken up into 3 different or 4 different materials here. I've got his ammo assigned to one material, and again, UV'd and laid out into a 0 to 1. He's a little unwieldy for a game engine right now. So what we're going to do is, again, optimize him utilizing the remesh functionality within InstaLOD. Now, different from the previous video where we had a high resolution mesh with no game res, what this basically is a very high resolution game res asset, or is an asset that's already UV'd, already has textures baked to it, and we're going to condense that down into something more reasonable. To visualize this, let's take a look at this image right here. So right now what we have is 11 different draw calls, so 11 different materials, each one of these colors representing a different material. And each material is going to have 1, 2, 3, 4 textures plugged into it. In this case, since he's PBR, he's going to have a base color, metallicity, normal, and roughness map plugged in. Each one of these maps is 2048 by 2048. And what we're going to use this remesh functionality to do this time is take all 11 of these materials and make one material, and all 44 of these textures, and drop it down to just 1, 2, 3, 4 textures in my new material. As you can see over here, we're going to make this a 2048 by 2048 texture for our new material. If you wanted to, you don't have to condense all of these textures into one 2048. Even if you were to double that into a 4096, you can see the footprint isn't going to be terribly large, certainly not compared to the original object. So it's not a deal breaker for your end result or what you're going to be using this in engine for, say, a character create or a game where you can have a 4096 assigned to your character. Assigning a 4096 may not be a deal breaker for you. Now that we have a little bit of a better idea of what we're doing, let's go ahead and look through some options here. Before we get into remesh, I'm going to go over here to optimize, and as you can see, this is just a polygons with materials and textures assigned. There's no skeleton or weighting involved. In possibly future videos, what we can do is under the optimize setting, you're going to see we have skeleton optimization as well. So while we're optimizing this mesh down into LODs, you can also optimize a skeleton and keep your weighting as you go. We're not going to be doing that in this video, but like I said before, possibly in future videos, we'll get around to that. But for now, let's hop over to the remesh tab, and let's take a look at a few of these options here. So we're going to see at the very top here, we have reconstruct or optimize. We're going to go ahead and keep it on reconstruct. Our fuzzy face count target is normal. If you want a higher resolution mesh, feel free to pick high or highest, or if you want to output this to something that doesn't need that much polygon fidelity, feel free to choose low or lowest. And of course, if you want to, you can choose maximum triangles and just dial in a number if you have a pretty good idea of the target that you're looking for. I'm going to go ahead and keep this on fuzzy face count target normal. And then under the resolution for surface construction, I'm going to keep this at normal as well. If you really only want to maintain the big shapes, the overall forms of your mesh, go ahead and choose low or lowest. Or if you want to maintain even more detail in your polygons, choose high or very high. Of course, it's going to probably slightly raise your poly count, or keep detail in areas that you may not need depending on their screen area. So I'm going to go ahead and keep this at normal as well. Down here under UV, I'm going to keep the unwrap strategy at auto. Gutter size in pixels at 2. Feel free to raise this if you need to. And everything else looks fine. I'm going to go back up here, and we're going to hop over to the Bake Output tab. And underneath the output folder and file names, go ahead and choose the output path. Just browse to a folder where you want to have these textures go to. Hit select folder. Feel free to change the file name format if you want. For the default width and default height, we're going to start with a 2048, and you're going to see down here super sampling is set to ×2, which basically means it's going to bake a 4096 map and then resample that down to a 2048 by 2048. Now, because we're doing that down here where it says 16 BPP, I'm going to change this from the default to the PNG 8 dithered. What that's going to do is on your normal map, as it's resampling, it's going to dither for you so that you get reduced banding on your normals. Down here at the bottom, you're going to see we have tangent space normal checked on as well as custom materials checked on. Basically, what it's going to do is take the tangent space normals that are pre-existing on your mesh and rebake all that detail down to new UVs. Now, because it's going to be putting those on new UVs, and those new UVs are probably going to be changing rotations, you can't just transfer the tangent space normal information. So it's essentially going to rebake your tangent space normal onto those UVs using your pre-existing tangent space normal. Where we have the custom material textures, again, because this is a PBR mesh, we're going to have a base color, metallicity, normal, and roughness texture plugged into here, and it's going to keep all of those as our custom material textures. And really, that's all I'm going to need to bake. If you scroll down here to the very bottom under tangent space, you can see down here you can either do OpenGL or DirectX. And also if you hover over these, you're going to see binormal. You're going to want to set this to on if you're going to Unreal Engine. So I went ahead and check that on just in case we go to Unreal. Unity is going to have this off. And then the normalized TS per fragment, leave that on if you're going to keep it in Maya, and keep it off if you're going to go to Unity or Unreal Engine. Going back over here to the Remesh tab, there's one more thing I forgot to talk about. We have distinct construction down here. Basically what it's going to do is, if I click on him, you're going to see all of these different pieces of his mesh are all separated out. If you want to keep those things separate, go ahead and check distinct construction on. But basically I want to voxelize this or combine all of this and remesh this into one airtight mesh. So I'm going to go ahead and leave that distinct construction turned off. Now that I'm ready to remesh this, I'm going to go ahead and select my mesh over here. If you have multiple meshes under a group node, just select that top group node if you want to remesh all of those together. In this case, he's just one object here, so I'm just going to select him, go down to the bottom here, and hit Remesh Selected Meshes. All right, now that that's done, if we scroll down here, you're going to see the operation took 72 seconds, so just over a minute. And I'm going to go ahead and move our object over here to the side, and let's take a look at what we've got. So as you can see, when I select that mesh, we went from 225,000 down to about 26,000 polygons, much better. And he looks a little bit flatter because if we go in here to our hypershade, you're going to see it made it a new material, and that new material is a Lambert. So what I'm going to basically do is quickly switch this over to a Stingray shader so these two we can evaluate these two. So I'm going to go over here to Lambert and give this a Stingray PBS shader. Then again, really quickly, I'm going to scroll down here. I'm going to say we're going to use a color, normal, metallic, and roughness. And then down here for a color map, I'm just going to plug those in. I'm going to browse to that output folder we just baked to. And for the color, I'm going to go ahead and grab the color texture. Let's go ahead and right-click this graph network, double-click this one. And for the normal map, let's go grab our normal. Metallic map, of course, we're going to plug in our metallic. And for our roughness, we'll just grab our roughness here. There we go. So now they look a lot more similar here. And again, if we select our original mesh and we look at the UVs, you're going to see all 11 of those texture sets are basically overlapped. So if I go through here and again, right click and say select objects and grab his body, you're going to see there's his body UVs. So he has 11 draw calls worth of UVs stacked on top of each other right now. If we select our new object here, you're going to see he's just one solid object. And these are his UVs here. And the reason why I have this button up here, which is our texture borders turned on, is so when we look at here, we can see where those texture borders are. However, and you can kind of see where it's cut across. And if we deselect him and we look at where those cuts are, you're not going to notice any sort of border edge. The tangent normals that we've rebaked to our new mesh is taking care of any sort of cuts across here. So you're not going to see any sort of seams across here. It's going to transfer flawlessly. So again, going from 225,000 down to 26,000, and this many textures down to just our 4 here. And again, if you wanted to see what those 4 they baked, this is our color, metalness, normal, and roughness. So all of these textures are baked down to just 4. So we dropped considerably the poly count and the texture footprint. And you can see transferred pretty good. These two guys look pretty similar. Let's go ahead and turn this light around here so we can see the back. I can't really tell the difference from here. Now, of course, if you wanted to, if your game will allow it or your budget will allow it, when you go over here to InstaLOD and you go over here to your bake output, you could put this up to a 4096 by 4096 and gather even more detail from your original asset over here. But for me, 2048 looks fine. And at this point, if you watch the previous videos in the series, you could even take this mesh right here and go ahead and instantly knock these down to your different LODs with another button press if you want. Anyway, that was the basics of remeshing, going again from a very high resolution, very resource intensive mesh down to a much more optimized mesh and not really losing a whole lot of visual fidelity in the process.